Welcome to Creative World. In this video, we will solve Chapter 2 Exercise Problem number 2.95. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.95. Find the value of current IA in given below figure such that voltage V0 is equal to 12 volt. This is the circuit diagram of given problem. Inside this network, we have to find the value of this constant current source labeled as IA. While one condition is provided in this scenario, voltage value across this 4 ohm resistance is 12 volt. So without wasting time, let's proceed towards the solution. First of all, we will calculate current through this 4 ohm resistance because value of voltage across it is known. So using Ohm's law, current through this resistance will be equal to 12 volt divided by 4 ohm. It will become 3 ampere. And the direction of current will be downward because in order to make this terminal positive, the current should enter from this terminal and leave from this terminal. Because of series connection, this same current with same direction will also be flowing from this 4 ohm resistance as well. So we can calculate voltage across this resistance, that will be the product of current through it and the value of resistance. It will become 12 volt also. Modify the network by indicating voltage across this 4 ohm resistance and current through this branch with its polarity. 3 ampere current is flowing through this branch in downward direction and voltage across this 4 ohm resistance is 12 volt with this polarity. Polarity notation of voltage is taken according to the direction of current. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 9 ohm resistance so that we can calculate current through this resistance that is labeled as Ix. We are interested to calculate the value of current Ix because voltage across this dependent voltage source is depending upon the value of current Ix. Polarity notation across this 9 ohm resistance is marked according to this assumed direction of current inside this loop. Write Kirchoff's voltage law equation for this closed loop. Start from here. Current entering terminal is positive, so 12 volt will be taken with positive sign. Next, current entering terminal is positive, so 12 volt will be taken with positive sign. And next, voltage source current entering terminal is positive, so voltage of this voltage source that are also 12 volt will be taken with positive sign. Next, current entering terminal is positive, so voltage across this 9 ohm resistance will be taken with positive sign, and all of these are equal to 0. Add these constants together, their sum will be equal to 36 volt and place this 36 volt on the other hand side of equal to calculate voltage across 9 ohm resistance, that will be equal to minus 36 volt. This minus sign along with the value of voltage is indicating that we have taken wrong polarity notation across this 9 ohm resistance. Actual polarity notation across this resistance is opposite to the assumed polarity. So modify the network by indicating right polarity notation across this 9 ohm resistance and the value of voltage as well. Now with this polarity notation, 36 volt is appearing across 9 ohm resistance. Now we can calculate current through this resistance using Ohm's law. Current will be equal to 36 volt divided by 9 ohm. It will become 4 ampere. So 4 ampere current will be flowing from this branch in downward direction, and because of series connection, value of Ix will also be 4 ampere. According to this value, we can calculate voltage across this dependent voltage source, that is the 2 times of Ix. So 2 multiplied by 4, it will become 8 volt. So 8 volt will be appearing across this dependent voltage source. Modify the network. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 7 ohm resistance so that we can calculate current through this branch. For that purpose, I am assuming the direction of current in clockwise direction. Write KVL equation for this closed loop. Start from here, current entering terminal is positive, so 36 volt will be taken with positive sign. Next, current entering terminal is positive, so voltage across 7 ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so 8 volt will be taken with negative sign. Now subtract 8 volt from 36 volt, it will become 28 volt, and place this 28 volt on the other hand side of equal to calculate voltage across this 7 ohm resistance, that will be minus 28 volt. Again, this minus sign is indicating this polarity notation is wrong. Actual polarity notation across this 7 ohm resistance is positive sign here and negative sign here. Now we can calculate current through this 7 ohm resistance. Now we can calculate current through this branch, that will be equal to 28 volt divided by 7 ohm. It will become 4 ampere, and the direction of current will be left to right because current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. Modify the circuit by indicating current through this branch. Current through this branch is 4 ampere and it is entering towards this node. Now on this node, two currents are entering and both are same values, 4 ampere and 4 ampere. So we can calculate current of this branch, that will be equal to sum of both currents, and this branch current will be leaving from this node. So their sum will be 8 ampere. 8 ampere current will be flowing from this branch and it will be leaving from this node. It means its direction will be downward. Modify the circuit by indicating this branch current. Now we will apply Kirchoff's voltage law inside this outer loop to calculate voltage across this 4 ohm resistance. For that purpose, we are assuming the direction of current in clockwise direction. According to this assumed direction of current, polarity notation across this 4 ohm resistance is marked. Write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so 36 volt will be taken with positive sign. Next, current entering terminal is negative, so 12 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 4 ohm resistance will be taken with positive sign. And at the last, current entering terminal is negative, so 8 volt will be taken with negative sign. Add 8 volt and 12 volt together, it will become minus 20 volt, and subtract 20 volt from 36 volt, it will become 16 volt. Place this 16 volt on the other hand side of equal to calculate the value of voltage across this 4 ohm resistance, that will be equal to minus 16 volt. Now again this minus sign is indicating polarity notation across this 4 ohm resistance is wrong. Modify the circuit by indicating right polarity notation across this 4 ohm resistance along with the value of voltage. We can calculate current through this 4 ohm resistance because voltage across it is known. So value of current will be 16 volt divided by 4 ohm, it will become 4 ampere, and the direction of current will be downward direction. Modify the circuit by indicating current through this branch. Now on this node we know the value of all entering currents. Only one current is leaving from this node and we are interested to calculate its value. So we can apply Kirchoff's current law on this node to calculate the value of current IA. For that purpose, first of all we will add all entering currents towards this node. 4 ampere plus 8 ampere plus 3 ampere minus leaving current, that is IA. Add these currents together, their sum will be equal to 15 ampere, and place this minus IA on the other hand side of equal to calculate its value. So the value of IA inside this network will be 15 ampere. So this was exercise problem number 2.95. Thank you. See you again in next video.